4 that today we'll discuss. After that, we'll move to next unit. Before going towards the types of thread, you should know what is a thread and why thread is used. Thread is a basic unit of CPU utilization. And before thread, you should know what is a process. Can anyone tell me what is a process? Process is a small program which is in execution. When one program is there and when we are going to execute that program, at that time we can say this is your process. So this is your process, and thread is nothing but the some part of a process, or you can call it as a lightweight process. And another one more definition regarding thread is that it is a basic unit of CPU utilization. A thread is a flow of execution through the process code with its own program counter. Process has its own program counter, system register, and stack. It provides way to improve application performance through parallelism. That means execute two threads or two processes parallelly. Because of this, we can say the application performance is increased, and this may happen because of the thread. And each thread belongs to the exactly one process, and no thread can exist outside a process. So when we'll see the diagram in that way case, you should realize what is a thread. See the diagram which is present on left hand side, that is single threaded process, and the diagram in right hand side, it is a multi-threaded process. Single threaded process contains code, data and files. Every process has their own code, data and files. But whenever new thread is created, at that time thread creates its own stack and register. See the left hand side, we shows the code segment, data segment and file segment, as well as registers and stack. And one thread is there. This one is your single thread. When we are moving towards multi-threaded process, that means we are doing a process parallelly. Here is your first process, this is your second process, and this is your third process. That is what thread created multiple process creates its multiple threads, and every thread has their own registers and stack. Register and stack contains the data regarding that particular thread, and code, data and files, these three segments which is common for all thread. That means we can say this is common for all process. And a process contains different threads. A traditional or heavyweight process has single thread of control. If process has multiple thread of control, it can perform more than one task at a time. This code contains the instruction. This code contains this one code. This code contains the instruction of process. The data, it contains the global variables, whatever present for that particular process, and this file contains the list of files which are open. So remember, this code contains the instructions of the process, and this data segment contains the global variable, and these files contain the list of files which are open, and this register contains the program counters. Program counter means what? It shows the which next program is ready for the execution, and this stack contains the whenever function is called, then parameter of that function as well as local variables are stored. That means we can say this stack contains the local variable. For storing local variable, every thread create its own stack. Okay, all of you getting? Now see the example. When a web browser might have one thread display image or text while another thread retrieves the data from the network. This is the example of multi-threading. When we are going to browse some data, one thread display a image or text while another thread retrieves the data from the network. This is the one example of multi-threading. Second example is what? When a word processor may have a thread for displaying a graphics, another thread for responding to keystrokes from the user, and third thread for the performing spelling and grammar checking in the background. Suppose I am going to open a Word file. Now see the example of multi-threading. This is your blank document. So this is your Word file. Okay. So one thread is for graphic purpose. Second thread is what? Which allow me to write some text on the window. Suppose I am going to write something. So whenever we perform some operation like spelling check and all, so next thread is going to check for the spelling. This is how we are performing multiple tasks at a time. This is the multi-threading. One is for displaying the graphics, one is for typing, another is for showing the grammatical mistake and all. This is the how we are going to perform multiple operations in a single process. This is the second example of thread. Now see the third example which shows a busy web server may have several clients concurrently accessing it. This is the third example of multiple threads. Now see the difference between process and thread. Process means what? A program in execution. So we can say that process is a program and thread is what? Thread is a some part of a process. So we can say thread is a lightweight process or it is a some part of a process. But as compared to thread, process is a heavy weight. Okay, this is the first difference in between process and thread. Now see the second difference. This one second. A process switching needs interaction with operating system. Here your word file is your one process, okay? And the typing on that word file as well as highlighting the text and showing the errors which is present in your spelling. This is what the different tasks that perform by the thread. And whenever we want to communicate between two process, suppose your word is one process, notepad is another process. In that case, process switching needs a interaction with operating system. We, without any interaction, two process or process switching is not possible. But thread switching does not need interact with operating system because अगर आपने एक प्रोसेस ओपन किया है और प्रोसेस के अंदर साइमल्टेनियसली डिफरेंट टाइप्स ऑफ ऑपरेशन परफॉर्म कर रहे हैं इन दैट केस इंटरेक्शन इज नॉट रिक्वायर्ड बट व्हेन you want to communicate between two different process, or you want to switch in between process, in that case interaction is needed. This is the second difference regarding the process and thread. Now see the third difference. In multiple processing environments, each process executes the same code but its own memory and file resources. Every process has, here in diagram we have already discussed that every process has their own code segment, data segment and file segments. So what third difference says? In multiple processing environment, each process executes the same code, but its own memory and file resources. Yes, right. Because every process has its own memory and own file resources. But when we are seeing regarding the threads, in that case, all threads can share same set of open files and child process. This is the third difference. Now see the fourth difference. If one process is blocked, then no other process can execute until the first process is unblocked. Because at a time एक ही process run होती है on the OS. So अगर एक process block होती है तो we cannot perform the another process. But this thing is not possible with the thread, because while one thread is blocked and waiting, second thread in the same task can run. That is the fourth difference. Now see the fifth difference. Multiple process without using threads use the more resources. But in case of thread, multiple threaded process use fewer resources. Now see the last difference. In multiple process, each process operates independently for the others. But one thread can read, write or change another thread's data. This is how the last difference regarding the process and thread. Now all of you getting the difference between process and thread? Now see what are the advantages of thread. Thread minimizes the context switching time. This is the first advantage. Second, use of thread provides concurrency within a process. That means we can perform process fastly. Thread is having efficient communication as well as utilization of multiple processor architecture to great scale and efficiency. These are the some advantage while using a thread. Now see the what are the disadvantages of thread. Blocking of parent thread will stop all child thread. This is the main disadvantage of thread. Now see what are the different types of thread. Basically there are two types of thread. One is system, one is user thread, and second one is kernel thread. Wait, I will minimize this. Now see the multi-threaded model. Before going towards multi-threaded model, you should know what are uh, two types of thread. One is user level thread and second one is kernel level thread. And this level thread is managed by the user and the kernel level thread is managed by the operating system. The operating system manages the threads acting on a kernel, and in kernel level thread, operating system has a main role. And the some operating system provides a combined user level thread and kernel level thread facility. Example for the user level and kernel level thread is Solaris. Now see, basically there are three types of multi-threading model. One is many to one model, second one is one to one model, and third one is many to many model. What do we mean by these models? Firstly, we'll see what is a one to one model. In one to one model, every user thread needs one kernel thread. If we want to suppose, if we want to execute 20 process, for 20 process 20 users need, that means 20 user threads are there. So in one to one model, for every user, every user one kernel is there. So for executing 20 process we need a 20 users as well as 20 kernels, and these kernel threads needed by the operating system, or we can say operating system creates the kernel thread. So it is very burden on operating system performance of the computer, because we have to create a kernel for every user. So it is a time consuming as well as it is a burden for OS. So it reduces the performance. To overcome this, we use the many to many model. जितने भी process है, for every process we need a one kernel. So this is what one to one model means. For one user thread, one kernel thread should be there. So here this is process. In process one thread is there, and for one thread one kernel is there. See the second process. In second process one thread is there. For one thread, or we can say for one user one kernel thread is there. This is what one to one model. To overcome one-to-one model, many-to-many model is used. See, this is the many-to-many model. In many-to-many model, there is no comparison between user thread and kernel thread. As per the requirement, user thread and kernel threads are called. Number of kernel threads may less compared to user thread. And this many-to-many model is best among these three models. Always remember, in many to many model, number of kernel thread is less compared to user thread, and this is the best model among these three model. Here user space is there. In user space, one process, that is process P1, and another process, that is process P2 is there. Process P1 contains three thread, that is 1, 2, 3. And here in process P2, three threads are there, 1, 2, 3. For threads, we are here for user thread, kernel threads are called. Here is one user, first kernel thread, this is second kernel thread, and this is third kernel thread. So here for three thread, for three user thread, three kernel threads are called. And here is again one, two, three. Three user threads are there. For three user thread, three kernel threads are called. We can say as compared to user thread, kernel threads are equal or it should be less. This is the many to many model. Now see the one to one, many to one model. In many to one model, multiple user threads you can use. but only one kernel thread should be there. For one process, one kernel thread is there. See here in process P1, three user threads are present. One, two, three. But for one process, one thread is assigned. This is the many to one model. See the process P2 which contains the three user thread. This is one first user thread, this is second user thread, and this is the third user thread. And for this whole process, one kernel thread is assigned. This is the many to one model. In many to one model, parallelism approach is not achieved because when we have one kernel, to overcome this one to one model is used. Now to implement threads, we use thread libraries. It provides the API, that is application program interface. API contains the collection of functions which are useful for creating and managing the threads. Basically, there are two types of thread available. One is P thread, that is POSIX, and second one is Java thread. And there are two ways to implement a thread library. First is a approach or first approach to provide a library in user space with no kernel support, where all code and data structure for library exist in user space, and the invoking of function in library is a local function call in user space, not in system call. And second approach is to implement in kernel level library, which is supported by the operating system. And the third library contains the code for creating and destroying the threads. All of you getting what is models of multi-threading models of the thread and types of thread. Getting? Now next point is a system calls.